So just like with linear equations, if I have two or more linear inequalities, we could call that a system of linear inequalities, like I got right here. And you can graph your linear inequalities and find the solution to that system. But instead of finding the single point where two lines intersect, we're going to find an entire region where any points in that region can be solutions to your system of linear inequalities. So just start by graphing your first equation. So we'll do this red one. Our y-intercept is -2. So I'll just go ahead and plot that point here. The slope is 5, or if I wanted to write it as 5 over 1, like rise over run. I will rise 5 and then run 1. So up 5, 1, 2, 3, 4, 5, and then over 1, I'll plot a point. Again, 1, 2, 3, 4, 5, rise, and then run 1, plot a point. All right, and since this is y is less than, and not y is less than or equal to, this line is going to be a dashed line. So we'll do like that, and like that. That should be good. All right, and it's y is less than, so we're going to shade below the line, not above it. So all of this area, right, below the line, these are the solutions to this first inequality, okay? Do the same thing for the blue one. Start with your y-intercept, so +1, so I'm going to put that right there. And our slope, right, it's actually 1, right? Remember, even if there's not a number there, it's understood there's a 1 in front of that x. So 1 over 1 to keep it in rise over run. And so I will rise 1 and then run 1, plot a point. Rise 1 and run 1, plot a point. I'll just do this a couple more times, like that. All right, this is y is greater than or equal to, so this is going to be a solid line all the way through, like that. And it's, again, greater than or equal to, so that means we're going to shade above the line. So I'm going to do like this, right? And let me just bring back that red dashed line a little bit again so we can see it. So again, with systems of equations, we wanted to find the single point where the lines intersect. But with systems of inequalities, it's a region. So where do these shaded regions cross over? Where do they intersect? Well, that's going to be this area in purple right here. Any point in this purple shaded region is going to be a solution to this system of linear equations, and I'll show you what I mean. Take the point 5, 10, for example. So that's going to be like right about there, 5, 10. So since this is in that purple region where both of those shadings intersected, this should satisfy both of these systems over here. So let's check, right? We're going to take this top equation, and instead of y, I'm going to put 10 is less than 5 times x. Instead of x, let's throw a 5 in there and then the -2. So 10 is less than 5 times 5 is 25 and then -2. That's going to be 23. 10 is less than 23. That is a true statement, so looking good so far. If you do it again, this time with the blue equation, right, we'll have, instead of y, we're going to put 10 there, is greater than or equal to, instead of x, it will be 5, and then +1, that's going to be 6, so we'll have 10 is greater than or equal to 6, and that is also a true statement. And so that proves that any point in that region is going to be a solution to this system of linear inequalities. All right, let's go again. So take your first linear inequality there and graph that y-intercept, +1. So put that there. Our slope is -1/2, and I'm going to stick that negative sign up top to be -1/2, kind of like just how I said it. Again, that's rise over run. So I'm going to go down 1 and to the right 2. So down 1 and then to the right 2, plot a point. Down 1 to the right 2, plot a point. And since this is y is greater than or equal to, this is going to be a solid line. So it'll look something like that. And it's greater than or equal to. So we're going to shade above this line. Above this line. I'm going to make it a little bit longer. Okay, like that. All right, so that's the first one. And for this second one, y is greater than or equal to 3/2 x. Our y-intercept is 0. So I'll plot a point there at 0. And then we're going to rise 3, and then to the right 2. Rise 3, run 2. So I'm going to go up 1, 2, 3, and then over 2. Put a point there. Again, 1, 2, 3, and then over 2. And then since this is greater than or equal to, this is going to be a solid line. So I'll just draw that like that. And it's, again, greater than or equal to, so we're going to shade above that line. And again, you can see here, this is that region where both of those shadings from the individual linear inequalities, they intersected. So you can pick any point in that area, plug it into both of those linear inequalities, and you'll get true statements on both of them, and that's your answer. Okay, last one. You should be getting the hang of this by now. So start with your red one, graph the y-intercept. That's going to be at -5. Your slope is 7, or 7 over 1, rise over run. So I'm going to go up 7 over 1. Up 7, 1, 2, 3, 4, 5, 6, 7 over 1. And then again, up 7, 2, 3, 4, 5, 6, 7, and then over to the right 1. This is y is greater than, just greater than, so this is going to be a dashed line. That. And for the blue one, our y-intercept is 1, so I'll plot that point right there. Slope is 5 over 4, so rise over run, up 5 over 4. 1, 2, 3, 4, 5, and then to the right 4. 1, 2, 3, and 4. And if I wanted to, you could do it backwards too. So instead of going up 5 and to the right 4, you could go down 5. So from here, 1, 2, 3, 4, 5, and then to the left 4. 1, 2, 3, 4. It's just less than, so this is going to be a dashed line as well. Like that. I should have done the shadings first, I guess, but that's okay. Y is greater than, so we're going to shade above that red line. Like that. And then less than the blue line, so I'm going to shade below that. And you can see here, kind of tough to see, but maybe if I was using pencil and paper, it would have come out a little bit better. But there is our range of solutions for this system of linear equations. So pick any point in here, right, and plug it into both of the equations. You'll get true statements for both of them, and that's it.